Hello, welcome back. Just quick integral again today, indefinite integral, toughish. We'll have a look at this. I'm just going to warn you, I've got a new microphone here and it's making some funny noises. It sounds like sometimes like I'm breaking wind. It's not me, I promise you, okay? Just a total waste of time, of money probably, this thing, but we'll give it a go today. So hopefully it'll be all right and recording fine, guys. Okay, you can always find this kind of integrals in my site. This will be this particular one. Probably you will find it under booklets, further integration, and I think if you go to try to think now the name of the booklet, indefinite mix or something like that, you will find this integral. I think it's probably past the number 700 or something. Okay, let's have a little think how we're going to approach it. First of all, just a couple of observations. This 4 here makes absolutely no difference into the method of the methodology rather, because all it does, it makes the answer 4 times larger, and therefore it's purely there, probably I suspect, to make the answer a little bit neater at the end and nothing more. What should we be doing for something like this? My gut feeling, first of all, is to use a substitution to remove this square root. But at the moment, I've got another little voice in my head that is telling me, possibly, I'm going to try this actually first. I'm not going to remove the square root by saying u is equal to the square root of all of this. I'm going to actually try a trigonometric substitution, because this looks like I can form there the identity 1 plus tan squared. Maybe I can go hyperbolic, I'm not quite sure. Okay, so just a little try. I'm going to use a substitution and I'm going to go trig. So I'm going to say x squared is equal to the tan of theta. This is not my actual substitution. I'm writing it like this because, of course, it helps me here. But the actual substitution is, in fact, I have mentioned that in the past perhaps, is theta is the arc tan of x squared. Okay, so I hope that makes sense. So now I'm going to, before I do that, let me just do a little right angle triangle for this. So I have it ready, because remember this is now a one-to-one function as I have it in there. So this is the angle theta. So I've got x squared over 1. You can see from here the tan of theta is x squared over 1, and therefore the hypotenuse will be x to the 4 plus 1, which I've got up there, which of course motivated me to do this particular thing. I need to differentiate now and make the x the subject. So as it is up there, 2x dx is equal to sec squared theta d theta. Probably I'll go back into tans, or shall I just leave it like this? Let's actually make the dx the subject first of all. Dx is equal to, and then we got a sec squared theta d theta divided by 2x. I think that's good enough, because if you see this x there, this will go at the bottom, it will cancel it. So that actually looks good. So let's put our bits in. So my integral now will transform to 4x, just leave him there because of course it's going to cancel. I called this, I'm going to put the extra line, x squared is my tan, so that's going to be a tan squared of theta plus 1 inside the square root, and my dx is now a sec squared of theta over 2x over 2x d theta, and a lot of cancellations are now taking place. First of all, this 2x will make that into a 2, and this is an identity, which of course is a sec of theta, oh no, and another sec squared, and that gives me, and it's not, I said oh no because this is not a nice integral to do. A while back I used to do a lot more integration. I used to remember the answer to this one. That's how much I hate this particular one. I don't quite remember the answer to this. I know it's got probably something like a half, so that's the sec cubed of theta. It requires a little specialist technique. You need to have seen how it's done. And I hope I remember how to do it now as well. Log I think is the sec theta plus tan theta together, and then they appear in a product. I think it also has a half, and then now as a product sec theta tan theta, something like that. I can't remember if it's plus or minus in there, so we'll have to play around with it and just come up with the answer now for this particular one. Okay, so let's do we need any of this? We need just the substitution. We don't need the dx. We might need this triangle to go to get other things though, so let's leave the triangle in there, and let's try to do the integral of sec theta. Let's not forget, I actually made a mistake in here. There's a 2 which I have forgotten, and I was already gonna go wrong with this. So let's think about how we're going to integrate that, and if I remember myself now, shall I do it as a 2 sec cubed, or shall I do it as just sec cubed is the next question. Let's leave the 2 in there, because I think the answer has half, so if I leave the 2 I'll get whole bits. So 2 sec cubed theta d theta. I'm going to split it into two things first of all. So I'm going to say this is equal to 2 sec theta, as it was originally essentially, 2 sec theta, and the other sec squared, I'm going to go identity 1 plus tan squared theta d theta. Okay, so that's my first step, and then I'm going to multiply. I can see that bit okay because I remember the answer. I'm going to multiply that, and the first bit that you just saw there was the integral of a sec. So 2 sec theta, that's this bracket, plus 2 sec theta tan squared theta d theta. I hope my mic is holding well and it has it's not making silly sounds. Okay, I'm going to split the integral, but I'm not going to split. I'm going to do it as I'm going along. The integral of 2 sec, I'm not showing where is it coming from. You should know how to integrate that, and you can quote it, is in fact for this particular one 2 log sec theta plus tan theta. Okay, so that's the integral of 2 sec. The rest, of course, is still to be integrated. So plus the integral of 2 sec theta tan squared theta d theta. There's parts in there somewhere. I just need to think for a second how I'm going to do these parts, which way I need to do this. Probably we write here sec tan times the tan. Let me just write it. I'm not sure if that's the right way, but I'm going to attempt it in a second. So I'm going to let me write it in red underneath. I need to see it before I do anything. So 2 sec theta tan theta, which is a differential, times a tan theta d theta. So if I do this by parts, what will happen in there? This will be the derivative, so it's going to bring me back to a sec theta, and the tan will differentiate to sec squared. Yeah, that's the way I want it. Okay, so in fact I'm going to write now my integral there as 2 sec theta tan theta multiplied by tan theta d theta, and then I'm going to do my integration by parts. I'm going to solve the integration by parts here. I'm not very well organized with the board where I put things, so let's rub this line off as well. This is how I do my parts. Of course, you might be using formulas or similar kind of little sorter grids. So I'm going to put my 2 sec theta tan theta on the bottom right, and this is the exact differential of 2 sec. Sec differentiates to sec tan, so that's good. And I'm going to put my tan on the top right. I'm going to differentiate it so it goes sec squared, and it will produce a sec cubed there, and this is how this integral is done. Okay, so this is all good. So the answer now, going to the next line, is of course exactly the same thing here. I'm just merely recopying it. Sec theta plus the tan of theta. I'm going to get out of the way to see the grid. Okay, and then we have the integration by parts, which is the product of this column. So that is going to be plus 2 tan sec, 2 sec theta tan theta, as I remembered it in the beginning. but so it's a plus or is it a minus? We'll see anyway in a minute. So, and then we got minus the integral of this diagonal. So that's 2 sec cubed theta, 2 sec cubed of theta d theta. And of course, if you haven't seen this integral before, I'm going to rub off these workings. And what happens is you create, in fact, it goes back to the integral you started. So if you look at what we've done so far, I'm going to put it here. All of this is, in fact, 2 sec cubed theta d theta. The integral of that is equal to that plus that minus that. So I'm going to put the sec cubed of theta integral together. You remember we were minus there. So we got basically, I'm going to write a little bit bizarrely because that's how I want it. Because in my integral that I'm trying to find, I need 2 lots of sec cubed theta. So I'm going to put the altogether. I got 4. Negative 2 is going to come there and give me 2 plus another 2 is 4. But I'm going to write it as 2 lots of 2 sec cubed theta d theta is equal to 2 log sec theta plus tan theta. So the formula that I was remembering wasn't that far out. It's actually a plus, and it does have a half. So that's plus 2 sec theta tan theta, and we're going to put the plus in now if you want. And of course, now this 2 that appears in all of them, I'm going to lose it. 2 from there, 2 from there, and 2 from there. So the integral that I'm trying to find, which is here, is in fact equal to that. So I'm going to make some room. Let's make some room up here, because of course we have to go back into x. So that's practically done now. All the work is done. It's not that bad. It worked out a lot nicer than I thought. I thought it was going to be a lot more complicated, this thing. So here it is. I'm going to put an arrow. So let me move out of the way so you can see all the bits and pieces. So this is actually this line here. Let's copy it up there. So that's equal to log sec theta plus the tan of theta. Was it plus sec theta tan theta plus c. No mistakes in there. No, okay. And now we need to go back into x, and I'm going to use this little grid here. Of course, the tan of theta I have it is just x squared. I need to get secs from this little triangle, and if you look from this triangle now, the cos of theta is going to be 1 over the square root of x squared plus 1. So therefore the sec of theta will be just the square root of x to the 4 plus 1. So I'm looking at this line here and this line up there. So going back into my integrals, that's going to be the log of sec plus tan. I'm going to put the tan first, so it's x squared plus the square root of x to the 4 plus 1. I don't actually need mods for this one up, just put mods because this expression is all positive. So normal brackets will do, plus sec times tan. And the sec times tan is, of course, that's my tan, x squared. And my sec is the square root of x to the 4 plus 1 plus c. And I think this is our answer. It wasn't as bad as I thought. I was expecting a lot tougher actually for this particular one. So it was done actually a lot neater. I'm just wondering what would have happened if I had gone for a substitution, because my initial thought, as soon as I saw that, I thought u is going to be the square root of x to the 4 plus 1, get rid of that square root, but it wasn't actually necessary. Probably will merge with this particular method at some point, okay? So I hope you enjoyed that. On that note, no more for this particular one. Who's laughing now? I will see you real soon, I hope. Okay, bye for now.